Hi, so today we're going to be using an LCD, and there's a couple tricky things about an LCD, and this is for Lab 7 of course. So in the first, we're going to make this two videos. In the first one we're going to just show you how to use an LCD, and then that'll help you write your code. And then in the second one we'll show you how to wire it up on the board. So, unless you have some circuitry that makes your life easier and resets the LCD for you, you're going to have to use this little fancy algorithm that's available on the internet for free. And so we're going to send the command hex 30 three times at first, delaying by 20 milliseconds, then send the function set, which we'll discuss later, send the display clear, set the entry mode, and then turn on the display. So let's start at the beginning. We're going to send the command hex 30 three times. There's this simulator right here that makes our life easier and lets us check it out. So we're going to put in hex 30. And the enable pin is the latching value, and it latches on the falling edge. So we'll raise it up to 1, and we'll drop it back down to 0 to generate our falling edge, which will latch in the value. And our RS value tells us whether we are sending command or some data. 0 means command, 1 means data, so we have it at 0. And read write, we only will be doing write, so we'll leave it at 0. And we'll let it fall. So that's 1, 2, 3. We'll bring it up to 1 just to hold it there. The next thing, we need the function set. So over here, we have a table showing the function set. Well, here's the function sets. There's 4 of them. 2 8-bit, 2 4-bit, 1 8-bit, and 1 4-bit are 2 lines. The other 2 are 1 line. I like having the most amount of room, so we'll do 8-bit interface 2 lines, which corresponds to decimal 38. So we'll come over to the simulator. Here's the 3, 8, and we'll let it fall to latch in. Down here you can see what command you're actually sending to see if you're on the right track. And it says 8-bit mode on, 2 lines, 5 by 8, which means that we did guess correctly by following this table. The next bit, display clear. We go back to this table. Here's clear screen. It happens to be hex 1. Go back to our simulator, set them all off, turn it to 1, and sure enough it's clear display. Latch it in, and our display is clear, and you can see kind of 2 blank lines right there. The next part is the entry mode. Now this is the tricky part. There are 4 different entry modes, and they will look like this. This is trying to spell what this is, Dorelli, only it looks backwards, so I don't want that. This is trying to spell Hakan, but it's backwards, so I don't like that. Now these 2 are the ones that give it forward. This one moves to this way, or to the right. This one moves the text to the left. I read left to right, so I'm going to go with the one that moves to the right, and that is 6 in hex. So we'll go back to our simulator, put in 6, and the entry mode is to increase the cursor position, scroll display off, latch that in. Now we can't see our cursor yet, so we have to go and find out how to set our cursor. Back up at our function table, we have make cursor invisible. No, it's already done. Turn on visible blinking block cursor. That's what I want. So that's decimal 15 or hex F. So we'll go back to our simulator, input hex F, and we'll latch it in, and there's our blinking text. Now let's try to put in some characters. We'll start with H. So we're going to drive RS up to 1s to say that we're giving it data, and we're going to give it the ASCII value of H. Now the microprocessor in the LCD will translate the ASCII value into these pixel arrangements, and in all your code you should just be using single quote H anyways to say it's a literal value. So we'll put in H in this char section. If you want to do it by value, you'll have to go look up an ASCII table, look up capital H, and that'll give you the number. Or you can let your compiler handle it, which is the way I like to do it. And we'll latch this in, and there's our capital H. Let's try a different letter. We'll try E. We'll try to spell out hello. So lowercase e, latch that in. Lowercase l. Now we'll latch that in and latch that in. and then a lowercase o, and latch that in. Now, let's try to put world, the traditional hello world from programming, on the second line. So to that, we need to go and move cursor to a certain position. Oh, here it is. Set cursor position DRAM address, which is decimal 128 plus whatever the address is. Now if we look here, the addresses on line 2 are 64 to 79. So let's move it 128 plus 64, and we'll need to figure that out. So let's pull up a calculator. 128 plus 64 is 192, so let's try moving to 192. And we'll set this to data, or command mode, RS to command mode, and we'll latch it in. And there, sure enough, it goes down to the second line. Now let's try and fill in the rest of our hello world example. Latch in the W, latch in the O, latch in the R, an L, and a D. And so there you have it. That's how you program it. Now, one thing that I haven't really discussed yet, because we're using it manually, is that the transition time, the falling edge to a rising edge to a falling edge, has to be appreciable. You can't just immediately go click, 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 like as fast as you can in programming. When I'm doing it by hand, I'm too slow, so I don't really have to worry about the timing, but in programming you do. So what you do is you just set up a little delay. It doesn't have to be long, a couple milliseconds will do. But you just want to make sure that the microprocessor and the display have time to stabilize before you send your next byte. Otherwise you're going to get something that looks weird and you're going to be confused. So just make sure that you keep that on. Now the read-write, if you're really adventurous, you can learn how to use those. That'll tell you when you're allowed to send your next command. But on the PIC16F, you're going to be kind of short on pins anyway, so it's better not to really try to worry about that. Just try to get it running like this. Once you have it running, then you can go experimenting off with the read-write commands.